quick review of what was talked about in the first part of the 2627. So we talked about how to find vertical asymptotes, horizontal asymptotes, the X-intercepts, the Y-intercepts. We talked about how symmetry could help you graph these things, and then what to do to graph all of them, right? And then also to identify if there's a hole, okay? Let's start with vertical asymptotes because I think that's easiest, right? So vertical asymptotes are found how? Good. Denominator equal to 0. And then you had horizontal asymptotes. And for these, there's 3 different cases, right? It's not the same every time. So to determine which case it is, you have to look at the degree of the numerator and the degree of the denominator. So whatever, so let's say it's a x to the n for your numerator and a x to the n for your denominator. Okay, and we call that, well, they did n for numerator, m for denominator, right? So highest exponent in each is what you're looking at, not always first, but highest. If the highest exponent in the numerator is bigger than, actually let me go in the same order as what was on the notes, is less than the denominator, then your y, or your horizontal asymptote is at y equals 0. If they are equal, then it's the leading coefficient of the numerator over the leading coefficient of the denominator. And if it is greater than it, then there is no horizontal asymptote. With me so far? Okay, then we said that a hole happens when? Good. If you can simplify your numerator, so if it's x plus or minus a number, and in the denominator, something can be factored, plus or minus number, in which one of those factors cancels out. So if you cancel through something in your denominator, you lose that vertical asymptote, so it's no longer an asymptote, but it still is an undefined point. So there will be a hole at whatever that root is that you cancel through. So if I had canceled through x plus 1, let's say, in the numerator and the denominator, then I would have a hole where x equals -1. I would graph the rest of this function, and then once it's simplified, so it means you're not going to have that vertical asymptote, you would graph it. A lot of times it's a line, and on that line, wherever my x is -1 is going to be a hole. And then we talked about using symmetry to identify certain points on a function and how to find the x and y intercepts. So I'm going to start with what they're asking for here, which was the vertical asymptote and the horizontal asymptote, and then we'll make our way into finding the points and plotting these, okay? So let's start vertical. So, oops, daisy. So vertical asymptote, I'm going to set my denominator equal to 0. Because this is factorable, I would factor it first and see if I'm going to get a hole. So x plus 4, x minus 4. Do either of those cancel with my numerator? No. So there's no holes, okay? And I already have it factored, so I can just set each of those equal to 0. And I get x equals -4 and x equals +4. So I have 2 vertical asymptotes. Then I go to horizontal asymptotes. What's the degree of my numerator? What's the degree of the denominator? 2. Those are the same, which means I do leading coefficients. Y would equal the leading coefficient in the top, which is 4, over the leading coefficient in the bottom, which is 1, and y equals 4. Remember, these are equations, so they've got to stay in x equals and y equals form. You can't just give me a number. Okay, so let's start there. Vertical asymptote at 4 and -4. Horizontal asymptote at +4. So already you should have that. We good so far? Yep. Okay, now I need more information to graph this. So I'm going to go to my, actually it doesn't matter which order you do this in, but if you identify symmetry first, it will help you with the rest of it, right? So if I look at this graph, if I test for y-axis symmetry, I would get y equals 4 times -x squared over -x squared minus 16. And it goes back to the original, which tells you what? This is symmetric to the y-axis, right? If I change the y and the x, it's not symmetric to the origin. So that tells me whatever's going to happen on the right side is going to happen on the left side, okay? Because if you change, you'd have to change both the x and the y. The x would go back to normal, but the y is not going to go back to normal. Yeah. So already, hopefully there's some, if it's symmetric to the y-axis, that means I can't have a cubic function in the middle, right? That wouldn't be symmetric to the y-axis. I can't have up on the left and down on the right. That wouldn't be to the y-axis, sorry. That wouldn't be symmetric to the y-axis, right? Which tells me I'm looking at a parabola shape in the middle, and then both sides are either up and both sides are either down. So already that should help you. Let's say you had no idea about symmetry, then you just look at points. So now I'm going to go to my X-Intercepts. I'm going to set y to 0, so 0 equals 4x squared over x squared minus 16, okay? Now every single time you could do the same first step, which is multiply by the denominator. It's going to cancel out. Or save yourself the work and go straight to the numerators. So 0 equals 4x squared. Divide both sides by 4 and square root. What does this tell you about this 0? Multiplicity of 2, which means it's going to bounce. So I have this point now, and it should bounce, which confirms my symmetry. Yep.
How do you know that if there's y symmetry, then it's going to be a problem?
Because it can't be a cubic function. A cubic function goes up to the right, down to the left, right. You can't fold that at the y-axis.
Oh.
Does that make sense?
Yeah.
The question is, does it open up or does it open down? The only time it's going to cross through that the horizontal asymptote, because you can cross through it, is when it's cubic. So a parabola is not going to cross through it, which also tells you this is going to point away from it.
So it'll always be a problem?
If it's symmetric to the y-axis, yes. And it has two asymptotes, right? Because if it only has one asymptote, they could both be up or both be down. There would be no parabola.
Yeah.
All right, so then also I know with the parabolas that they point in opposite directions. So I'm pretty sure this is what my graph's going to look like. I'm pretty sure it's going to go up on the right and up on the left. The next thing I would try to find is the y-intercept. So if I plug 0 in for x, I get 4, 0 squared over 0 squared minus 16, and I get 0 over negative 16, which doesn't help me at all. I already have that point, okay? But your test is going to ask for both the x-intercepts and the y-intercepts. So then what's left for me to do is plug in points. Every range that is set up by your vertical asymptotes, you want to plug in at least 1 point from each range unless you are 100% sure about symmetry. So I'm going to start by plugging in something to the left of my vertical asymptote here, and the first one is -4. So I'm going to start there. So I would get y equals 4 times -4 squared over, -5, right? The 4 is the asymptote. I would get something that's undefined if I kept going. Yeah. And I get 4 times 25 over 25 minus 16, 100 over 9, which is 11 1/9. So confirming that I'm way up there at the top. It'd be up here somewhere. Oh, 11 1/9, like right there. Now I know my curve does that.
How do you know that it's like that?
How do you know what?
Like, how do you know beforehand that you know it's going to be?
Because parabolas, one points down, the other two point up, or the parabola points up, the other two sides go down. It's just the pattern with parabolas.
Oh.
Okay, so then again, we're 100% sure about symmetry, but if this was a test, I'd be like 1,000% sure, right? You can double check by plugging in a point that's now to the right. So I would plug in +5, and I'd get 4 times 5 squared over 5 squared minus 16. 4 times 25 over 25 minus 16. And I get 100 over 9, which again, 11 1/9. Again, I'm up here, and again, I know my curve does that. You can even plug in a point from this range to make sure that you're right in the pointing down of your parabola. So my advice is, especially on your test, so the way that your test is going to work is it's multiple choice for sections 2.4, 2.5, and then 2.6 and 2.7 is straight graphing. You're going to get 2 big graphs that ask you for vertical asymptotes, horizontal asymptotes, slant asymptotes, holes, X-intercepts, Y-intercepts, and then plot your graph. Plug in as many points as you need to make sure that your graph is correct, but don't waste time on plugging in too many points until you're all the way done with your test. Then go back and plug in additional points to check, okay? Don't get stuck on the second to last one and not be able to finish your last graph. So questions overall on what was covered. That was basically 2.6 and then 2.7 adds in the slant, but I just put them together because so much of it overlaps.
How do you find the symmetry then?
So I plug in negative x to see if it's symmetric to the y-axis. And then negative x and negative y, which means really if you've already done the x-axis or the y-axis symmetry, all you have to do is change the y for the origin.
Okay.
So you don't have to do all the work twice. You just have to change the y.
So is 2.7 just like the last 3
Just
slides?
slant. Yep. So we're going to finish that now. All right. So 2.6 and this is 2.7. Okay. 2.6 is basically just the introduction, the vertical asymptotes, the horizontal asymptotes, the domain review, right? All that stuff we talked about. And then we get into slant asymptote, which comes from your book in 2.7. A slant asymptote is a line that is slanted, so it has slope, okay? The way that a function has slant asymptote is if the degree of the numerator is 1 more than the degree of the denominator. So if the highest exponent in the top is 4, highest exponent in the bottom is 3, there's a slant asymptote. Highest exponent in the top is 2, highest exponent in the bottom is 1, there's a slant asymptote. If it's more than 1 different, so if it was like x to the 4th over x to the 2nd, there is no slant asymptote, okay? It has to be 1 different. Because the top has to be bigger than the bottom, you cannot have both horizontal asymptotes and slant asymptotes. You can only have one or the other or neither, because you can't have neither. If it was like an x to the 4th over an x to the 2nd, there would be neither. So you can have horizontal and vertical and slant and vertical. You can't have horizontal and slant together. Does that make sense? You can't have horizontal and slant, because horizontal, if the numerator is bigger than the denominator, there's no horizontal, right?
Yeah.
And it has to be 1 bigger than the denominator for it to have slant. The way you find the slant asymptote is by taking your numerator and dividing it by the denominator, and then you totally disregard the remainder and just grab the quotient, which will be a line. So it will be x plus or minus something, that y equals that is your slant asymptote. So you divide the top by the bottom, and then just take your quotient. Totally disregard your remainder. All right, so example 6 says, find the slant asymptote of the function of f of x equals x squared plus 6x plus 2 over x. So we know it has a slant because numerator in the top, or exponent in the top is 1 more than exponent in the bottom, right? And I need to divide the top by the bottom. This time you have options, right? Can I do synthetic? Yes, and I can do long division. But either way you do it, what's missing from the bottom? Is there a constant? What would the constant be? Plus 0. So you need it. You have to have it. If you do synthetic, which obviously I would recommend at this point, right? The 0 goes on the outside. It doesn't matter if that's positive or negative. Numerator has all the terms in order. Nothing's missing, so it's 1, 6, 2. Bring down the 1. Multiply 0 times 1. Put it in the next column. Add it. Multiply 0 times 6. Put it in the next column. Add it. This does not even matter. What's important is what's here. Nope. The first term gets your x. The second term's your constant. So typically the last factor would be this, and for slant asymptote, we just say y equals that.
How would you graph that?
I'll show you. Good question. All right, so let's say, it doesn't say to graph it, but I'm going to start it so you would see what it looks like. Let's say I have to graph this. Look at my initial function. Do I have a vertical asymptote? What is it?
0.
X equals 0, right? So that tells me I have a vertical asymptote that's passing through the y-axis. And then my slant asymptote is y equals x plus 6. This is a line, right? So I go to B being 6, 1, 2, 3, 4, 5, 6. I plot my point. My slope is up 1 and over 1.
How can you just ignore the remainder though?
Just for slant asymptote, you don't need it. So you're not saying that's the actual answer to the division problem. It's just that for the division problem, for slant, you only take the quotient.
Okay.
Yeah. God bless you. The top's not factorable. In this case, we would actually have to use quadratic to find your intercepts, which is why I'm not going to make you work all the way through this. But slant asymptotes, with a vertical asymptote, make some sort of an x, right? It's either a skinny x or a fat x, but it's some sort of an x. And your curves go in opposite corners. So the curve here would either be here, and you would know that by plotting points and getting the x-intercepts. Or it would be here and here. Same thing, you would know that by figuring out, as soon as you know your x-intercepts on this one, you would know what corners it goes in. But you would want to plug in a point to the right of your vertical asymptote, to the left of your vertical asymptote, and see where it falls. So you will graph with slant, it's just that this one is not factorable, so don't worry about it just yet. But if you got something like this, you would have to use the quadratic on that numerator to get your x-intercepts.
So the asymptote is the dotted line?
Correct.
Are we
Nico.
gonna do like slant asymptote, but then there's 2 vertical asymptotes, and they'll be like on opposite sides and nothing in the middle? Or
No. It's possible. I don't know if there's one in the homework. I think the one on the test would not be 2. But so you would just test, so it would be like this, and then like this, right? And then you have to figure out what your curve does in the middle, something like that, something like that. So they do exist. I didn't put it on the test. Yeah. All right, so this one kind of puts it all together, right? So this will be how a similar question on your test would look. Find the horizontal, vertical asymptotes, slant asymptotes, and holes. If there's none, you'll just write none. You're going to be asked to find your x-intercepts, your y-intercepts, your domain, and your graph. Okay, so make sure that you know how to do each of those individual parts. There's 2 like this. So I tend to start with vertical asymptotes just because I think it's the easiest, right? So, but before I even do that, I have to see, because if there's a hole, it means that you're losing an asymptote. So you want to check for that first. This time, both my numerator and my denominator are factorable, right? So if I factor the numerator, what do you get?
x minus 4, x minus 1.
Good. And the denominator?
X plus 2, x minus 2.
X plus 2, x minus 2. Do any of those cancel out? No. So I know already there's no holes. If one of those had canceled out, then there would be a hole. I would cancel it out, I would graph what's left, and then I would make sure that I put a hole at that spot. So now I can go vertical asymptotes. And because you've already factored, it makes your life easier, right? Just set each of the ones in the denominator equal to 0. And I get x equals -2 and x equals +2. Then I go horizontal asymptotes. So what's the degree of the numerator? 2. Degree of the denominator? 2. They're the same, so we're leading coefficients, right? Leading coefficient is the one that's in front of that highest exponent. In both cases, they're 1. So my horizontal asymptote is y equals 1. Is there a slant asymptote?
No.
Nope, because the one in the top is not 1 more than the one on the bottom, and also I can't have a horizontal and a slant. And there's no holes. So I can start with what I've got already, which is the vertical asymptote at 2 and -2. And the horizontal asymptote at 1. Again, you've already got some stuff. Now, I can use symmetry here also to test, right? So if I plug in a -x and a -x and a -x, I'd get negative y equals -x squared minus 5 times -x plus 4 over -x squared minus 4. So the first term goes back positive, the second one changes, and the bottom one goes back positive, but the other one is still negative. It is not equal to my initial one, and every sign is not the opposite, right? So I know there's no y-axis symmetry, which means what kind of shape's going to take place in that middle? That cubic function, not a parabola, right? Because that would mean symmetry. And then if I test for the origin, I would just make it negative y and set it equal to what I had, and that's not symmetric either. So it's not symmetric to the origin or to the y-axis. This time it doesn't really help us, but at least it helps us eliminate out the parabola in the middle. Now I go to x-intercepts. So 0 equals, again, I'm just going to use the numerator because if I multiplied by the denominator, it's going to go away. And I already factored it, x minus 4 and x minus 1. Set them each equal to 0, and I get x equals 4 and x equals 1. So 4, 0, and 1, 0. Don't forget, these are points. They need to look like points. If it asks for the zeros, I would list them. So intercepts are points. Zeros are a list. And then the y-intercept, so this time I'm going to plug 0 in for x. 0 squared minus 5 times 0 plus 4 over 0 squared minus 4. Cancels, cancels, cancels. Positive 4 over negative 4. Negative 1. With me so far? Yeah? Questions up to that point? All right, now get all that stuff on your graph. So 4 and 1 are my x-intercepts. 0, negative 1 is my y-intercept. All right, now let's talk about what this means, right? First of all, we think what kind of shape is happening in between those two vertical asymptotes? We think it's like an x cubed. Is that consistent with what my points are that are there? Yeah. If it was supposed to be a parabola, it would have to bounce back up, right? And then I should have had another x-intercept. Does that make sense? So already we're on the right track. We think it's probably this. We're going to confirm it because especially for a test, I'm going to make sure I'm 100% right.
But it couldn't cross the...
A cubic one can cross the horizontal asymptote. The shape of a cubic one, not actually cubic, but that shape can. And then with the cubic function shape in the middle, one of my curves on the outside goes up and one goes down. So if that point is already here at 4, I know it's going to look something like that. And if what we assume is right, that means that puts this curve up here, which is consistent with what we've got, because if it was under it, I would have had yet another x-intercept somewhere along this point. Does that make sense? So already I have this assumption. Now you want to back it to be sure. So if this is my test, if I'm taking my test, this is my second to last question, I would plot that. I would go to my last question. I would come back and plot my additional points. So to be sure that what I'm doing is right, I'm going to plug in something like -3 because that would be that would be in this range. So I want to plug in a point in this range. I already have the point on that side, and then I would plug in a point from this area here, like -1, to make sure that my curve is going down. So then, sorry, go ahead.
On the test, like, if we don't have time to check our work and, like, we only get, like, a point on the bottom right and we get a point in the top.
If you know that it's opposite and you know it's not symmetric, I'm fine with it.
Okay.
I would just apply your extra points to be sure.
Yeah.
That's all. Yep.
We're checking for the x cubed, and we plug in -1, and we get a number past -2.
If you're plugging, yeah, so if you get something that's above -1 in the in-between, you mean? Like if I plug in -1, right, I get -1 squared minus 5 times -1 plus 4 over -1 squared minus 4. I get 1 plus 5 plus 4 over 1 minus 4, and I get 10 over -3. So that's -3 and 1/3. if I got something like a positive 3 1/3 and it doesn't make sense with what my graph is, then you go back and you check your work and figure out why. But because it's negative 3 1/3, we were pretty close. There's my point. And then I would plug in one more point from the left of my furthest left vertical asymptote to be sure that the curve that I assume is in the top is actually in the top. So I would plug in negative 3. So negative 3 squared minus 5 times negative 3 plus 4 over negative 3 squared minus 4. I get 9 plus 15 plus 4 over 9 minus 4. This is 24 plus 4, 28 over 5, which is 5 3/5. That's higher than my horizontal asymptote. So negative 3 and 5 3/5 would be about here. So my graph that I assumed was there was actually there. So again, your test is going to ask for your vertical asymptotes, your horizontal asymptotes, your slant, your holes. It's going to ask for your X-intercepts or your zeros, your Y-intercepts, and then domain. What you use beyond that is up to you. If you can use symmetry to help you, use it. If you need to plug in points all over the place, do it. Just don't lose time so that you can't finish your test. Questions so far? Okay, so the very last part of this one just says use a graphing utility to verify. You're not going to have your graphing utility on your test. Don't use it for your homework. Make sure you can graph these. And the homework, there's a lot of multiple choice because it can't, like it's not as easy to graph these on your flash graphs. Make sure you can graph them by hand, okay? And then go back and check them from your graphing utility if it says. So I'm going to jump out and I'm going to graph it. Okay, so we graphed it on the graphing utility to verify. This is how you have to type it in. So you got to put the parentheses around your numerator, the parentheses around your denominator, and the divided by in between. Okay, and then our graph matches what we had. We have the cubic shape function on the right, the graph on the right, and then the graph on the left. Questions on any of 2.6 or 2.7? So again, to be super, super clear, the test questions from those sections will be open-ended graph questions. Okay, they're going to have multiple parts. Vertical asymptote, horizontal asymptote, slant, holes, X-intercepts or zeros, Y-intercepts, and domain, and then you're going to have to graph it. Sarah? It's next Thursday. So, all right, you find this one. So find the slant asymptote of the function. Again, you don't have to graph it just yet. Just find it. Can you do synthetic this time?
No.
Nope.
You said you divide the top by the bottom.
Correct.